Welcome everyone to today's demo of the RhinoFab 9700 combination machine. As people are still getting online and situated here, I wanted to just go over some quick controls for today. You'll see on the webinar control panel a mute and unmute button. Currently everyone is muted. And as we go through the webinar, we'll unmute everyone for questions, for any dialogue that you wanted to go through. But if you're watching, just make a point of keeping yourself muted to reduce the amount of background noise. You can also toggle between full mode by using this button, and to exit out of full mode, just hit escape. Now, if you do run into any type of technical issues, we do have staff standing by. You can take a screenshot or picture or write down these contact names, or you can also write a comment in the chat box or the question box, and we'll be happy to help you. Okay, so just to make sure things are working on our audience side, if you want to put in your state where you're from today, just go ahead and write that down, make sure things are working, and that way you're familiarizing yourself with all of the controls. All right. We got someone from Oregon, so we know it's working. Okay. Good stuff, good stuff. All right, with that, I'm going to turn it over to Bill Cole, and he is going to give a brief overview of the machines, a little bit of background, and then we'll go through a more detailed overview of the RhinoFab 9700.
Okay, everybody. My name is Bill Cole. I'm the Rhino representative, and I'm going to show you a couple things before we get started on the machine itself, the different machines that we have, and then a layout of the machine. And just for any of you guys that don't know our machines, we do have a conglomerate of machines. We have extrusion machines. We have, standard duty, light duty machines of different series. And about the only thing that changes on these are the saws. We have an individual door fab machine, okay, where you do door blanks only, right? And then we have the combination machines where we've actually taken our extrusion machines and our door blank machine and combined them so that you could actually run, curtain walls, storefront, pressure plates, cover caps, door blanks. You can run door rail, door jams, just about anything you can run through your shop, you can run through this thing. So this is what we've done. We've actually combined them now. In today's demo, the machine you're going to see is the 9700 combo. It's got the down cut miter saw and a separate bevel saw. And normally the machine, overall length of 67 foot. Normally we set these up to take a 31 foot 6-inch stock length. But today's demo, because of space limitations in our shop, we can only, I think we have it set up to take a 14 footer. So it's going to be a lot shorter, but that's just for demonstration purposes. The ones you guys will get takes 31 foot stock length. You can also get these to take a 24, so we can shrink these down quite a bit. I think the smallest we put in was a 50 footer, all the way up to a 70. So if you have any questions as we go on size and what these things are capable of, Walter and David are going to be here to answer questions for you. Okay. And as of now, I'm going to turn this over to Walter so we can get on with the demonstration. Okay, Todd?
All right.
Good morning and good afternoon, everybody. My name is Walter Lucanet. I'm a senior engineer at the Micro Group here, and I'm going to show you a few things from the system here that you see in the background.
Hey, Walter, we're just waiting for just want to make sure that everyone can see the video.
Oh, can you see the video?
All right, I'm going to unmute everyone.
You have to start over.
You can see.
It
Y'all can
didn't
see?
switch the screen.
There we go.
Now, you tell me when to go.
Looks like we're good. So yeah, go ahead.
Good morning and good afternoon, everybody. My name is Walter Lucanetter. I'm a senior engineer at the Micro Group, and I'm going to show you a few things about our combination machine, RhinoFab 9700. As Bill mentioned, here we're showing a 14-foot in-feed system, and obviously can go up to 31 foot 6 inches. Also, this is showing a 5-foot outer load system for stick fabrication. And it can also be up to 10 foot, so you can load 11 stock lengths rather than 6. And this in-feed is fully automatic, where these ball tables, where they're used for door fabrication, they go down when you do stick fabrication, and they come up, as you're going to see in the demonstration, when you do door fabrication. This is our push fit system, absolute positioning. So it always reads the absolute position of the pusher and not reading through the belt and be affected by temperature or anything like this. On our machine, we have a back router, a top router, and a bottom router, 3-axis fabrication with high-speed spindles, optional spindles of 36,000 RPM, 9 kilowatt, and they're for use with automatic tool changing. As you can see, the carousel here that has a 20 tool capacity with a robotic arm in the back. That blue thing you're going to see moving here in a little bit, that's going to automatically remove and replace tools on all 3 sides, back, bottom, and top. And then we have a servo-controlled clamping system. Because of that long stroke of 52 inches, the maximum door size you can put through is 52 inches. And this will go in a pre-clamp position. So it doesn't matter if you fab a 2-inch part or a 52-inch part, it moves quickly there. And then it's all fully automatic, adjustable with the pressure and torque in the parts library. So it's set up by the part or by the door. This way the operator doesn't have to worry about applying the proper pressure or torque for clamping. Over here, you're going to see the saw compartment. We have a top-down miter saw that can go from 45 to 135 degrees in 3 decimal places, servo-controlled. The stroke is also servo-controlled, and this also allows us to have the parameters in the parts library for the feed rate. And once this is set up for each different part, it's optimized, and the operator again doesn't have to worry about changing any of those settings, and you always get optimal cuts. And then on the outfit side, as Bill mentioned, we have up to 24 foot. And again, these rollers, they go up and down. If you run stick, the rollers come up and everything runs above the ball table. And again, these balls are very nice for rolling the door and spinning the door around without scratching. Anybody have any questions?
No questions so far, Walter. Thank you. Again, if anyone has any questions, you can easily write it in the chat, and we'll be happy to answer them. And also towards the end of today's demo, we'll have an opportunity while parts are being run to have a Q&A. So at this point, we're going to turn it over to Chris Draper, and he's going to do a quick overview of the software interface between for the RhinoFab. Okay, Chris.
Hello, everybody. My name is, you should be able to see my screen here. If Todd, if you just want to let me know if you guys see that, my Glazer Studio screen.
Yeah, it looks good from my end. Yep.
Okay. All right. So I'm Chris Draper. I've been with the Michael Group a little over 26 years now, and I'm one of the software engineers for the software. And today I want to just show you that both the Glazer Studio and the Partner Pack Studio, amongst all of its other features and everything, is just the fabrication side and how you work with blank door leaf and sticks and hardware and setting up libraries. So in this main screen here is where the sort of list of all your projects will be, and up here I've created this little door test project. And what this will allow us to do is you use Glazer Studio with the predefined libraries of metal systems that we built up from all the different vendors. We carry a lot of the vendors that are out there, and what we do here at Michael is we kind of set up the metal systems with all the fabrications and everything for you. But you also have the ability to add any custom fabrications to any part or piece that you may want to. So what we're going to be showing here today is, so like on this frame here, so you build your elevations and then you go through and you just place your doors, where you need them. And so if I edit this door that we've created here, and as you go down through and make your door selections, the different, styles, what type of locking, what type of hinging, the program's going to know, okay, this is the door that's going to match for this. So what we're going to do then is we're going to take this blank door leaf and we're going to send that down, out to the Rhino machine. But for hardware preps and all that, so if I come in here to hardware options and I look at, okay, well, I chose butt hinge, so I'm going to come to hinging. If I look at this specific butt hinge product code, I'm going to go and pull that up and I'm going to look at what fabrication preps I assign. So the way that the system works is you can build up a library. We have a pretty extensive library of different hardware fabrications for hinges and locks and panic devices, and I'll show you some of those here in a little bit. But for this specific case, I'm using this butt hinge here. And so I have this, what am I going to fab to the door? And then I can also set up fabs for the frame as well. So I'm going to apply this butt hinge, and then where are these locations located? So say I want a butt hinge at 10 inches, door height -10, door height divided by 2. So there's a lot of different formula options to help lay out the different hardware. Some hardware is always at a fixed location, and so you don't need to send in the locations that you want to apply the hardware. You can set that up to just automatically be at 36 inches or so I'm gonna go ahead and say okay here, and okay, and we're gonna go ahead and close this here. Okay, and so then once we put this door in and we can close out of here, then we can go, I'm not going to save that there. So when we come back to our main screen here, we've got several options. One is door fabrication. So this is going to be for just the door leaves themselves. Metal fabrication is going to be for all of our sticks. Now the sticks may be all of your framing components. You can also do exploded doors. If you're building doors, you can break out the leaf, and fabricate that as well. So then I was talking about this Fab Rules library. So this library is, is a library of all the different types of hardware. It's kind of an ever-growing thing, but this may include, so we've got some different things in here from, Von Duprin, from Glenn Johnson's, and some different, so you set up these libraries of all these different kind of components, and then you can either manually apply them or you can assign them to a piece of hardware. So under door fabrication here, I have this door test that I brought in. And so if I come in here and look, and this is the door that we're going to be running on the Rhino here. So this has, a 10-inch pull. It has, the 3 butt hinges along the hinge side and MS 1850 lock. And so the way this works is, in here, it knows what side it's going to apply those preps to and all that information. Some other options here is, so if I come to this little test I created, so you can set it up to manually do it, or another option is you can come into your add library and you can come in and we can select that same, butt hinge prep, and I can give it a location here. And then when I hit OK, it's going to automatically lay that out. So there's just some more options here. And then the final part of this is we're also going to run some sticks. And so I want to kind of show you that as well. So under metal fabrication, if I come and I bring up this one here, and so then I look at the sticks. So at different sticks here, what we do is when you build your elevations, we're already calculating what all the attachment pulls and preps are for that. But at the same time, you can come in here and you can manually add a line. You can add a library, you know, that same butt hinge for the door, you can add another butt hinge for the frame as well. But then as soon as you get all your fabs set up, then you would hit this output button, and then that would create the file to send directly to the Rhino. If it's on the network, you can just send it directly. So at the end, if you have any questions about Glazier Studio and how this works and all the preps or anything like that, we'll take those questions at the end as well. But I'm gonna send that back over, and so we can get that door fab.
Okay, Chris, thank you. I'm going to turn it over to David. And just a quick comment, the software and the RhinoFab machine have a direct connection, so it's really easy to just drag and drop the fabrication files, and it's ready to go at the machine side.
Okay. Am I up? Everyone can hear me pretty good? Got audio?
Looks good.
All right. I'm David. I think probably a lot of people know me already from previous Rhinos, and if not, I'm sure we'll get to know each other at some point here. What we're going to do is we're going to run a door, and we're going to actually run some curtain wall today. Yesterday, during the demo, if any of you guys were in it, we actually ran door jams with some butt hinges that kind of matched up to the doors, but today we're going to shift gears. We're going to run a little bit of curtain wall so you guys can see some of the countersinking stuff and the drilling with some miters and some bevels built into this stuff. But first, what we're going to do is we're going to run this door. I'm going to walk you guys through the process of how we typically do this and how the machine picks up all the information, interprets it, and applies it to the door. So I have this door. I'm just going to go ahead and set it onto these auto loaders here and walk you guys through general rules of thumb when you're running doors through the machine before we go over to the computer and start loading it. When you guys put doors into the software and you start programming things, as Chris kind of went over, you say, hey, I have a hinge left or a hinge right, and it swings in or it swings out. And what Chris does with all that data is he reinterprets it on the door so that we can tell you guys as the customers to just put the door through the machine the same way every single time, right? We don't want to flip this door over. We don't want to turn it and run it backwards. What we don't want to do is we don't want you guys to have to consider if it's hinge left or hinge right while you guys are out here running it. So when we build it in the software, we send the data all out accordingly so that the door goes through the machine like this every single time with the top rail going first and the pull side of the door up and the push side of the door underneath. And that just kind of takes a lot of the confusion out for the guys in the office, sending data out to the shop, making it so that you guys don't accidentally run anything backwards ever. We just kind of stick to the rule of thumb of this is how it goes and this is how we're going to do it. So if we come over to the computer, I'm going to pull this stuff up and I'll breeze through it so that I don't spend a bunch of time just looking at a bunch of numbers on a screen that you guys don't really care to see. But the user interface of the software is very similar to all of our other products, whether it's our stops or our smaller machines, the 900s, 950s. It's all going to kind of work the same way and integrate together. We're going to go to our fab job. I'm going to find our demo door here in the list. I'm going to click select, fab list. Here's some pages that you guys don't really need to worry about right this second. Here's one that's going to be a little bit different. That's a great identifier here. Basically, it's just saying, hey, which side of this door do you want to run first? Traditionally, we want to go with this side. That kind of helps keep us oriented with running the door through the machine the same way every time. But obviously, on the fly, if you know, hey, I just want to do the locks real quick, you can switch and say, hey, I want to run the lock side. But to keep things the right way, for now, we're just going to run the hinge side first. When we get to this list, it tells us what tools we need and what tools are loaded and not loaded. So from the office, they said, hey, on the top and the bottom, we need these router bits, and on the back, we need this countersink router. What we're going to do is, if we look into the machine, we can see that our top and bottom router are already loaded with the correct router bits. So I'm just going to go ahead and hit OK on these on the screen. and verify that I know those ones are in there. However, I know I need to change this one, so I'm just going to click this load button, and that's what's actually going to tell this robot to go to the carousel and grab the tool that we need. So I'm going to go ahead and click it. And what it does is it moves into a safe operating position. Carousel moves around to the correct position, and it's going to just reach in and it's going to grab that correct countersink router. Okay. Picks it up. It's going to switch and set down the other one that it has in its hand. This way, when it gets over to the tool, it can grab the tool out of there and also just rotate and switch them around. So it discharges it with an I/O digital input. Sets it down, and then the robot just parks itself back into a nice safe place. If we had more tools to load with the robot, he would stay out until we say, hey, you know, we also need this one and that one. But because we only need one, he knows, hey, I need to go back to my safe position so that I don't get hit by any routers or anything while they're running. So I'm just going to hit OK on this, make sure that we're good, and then I'm just going to hit next. It's going to pull me to my start page. And without going through too much crazy data, I'm just going to get this guy started up and push my door into where it needs to be. Okay, so we have our top rail going through first, and we have the pull side of the door up. And on this specific door makes the hinge side the start side. So I'm going to walk past. I'm going to hit this button here to say, yep, I've put the door in. It's our continue button. And it's going to start pushing through and doing its thing. So on this door, this is the one that Chris was showing you guys. This has actually got 3 butt hinges. It's got a electric power transfer EPT10, and that'll be it on this hinge side of the door. That doesn't mean that this is limited to those things. It's going to do ultimately anything that you tell it to do. So if there's specific hardware preps that you guys are wondering, hey, can this do panics? Can it do offset pivots? Anything along those lines, DVRs. Of course, it's just a matter of getting the data in there. And with this one, we decided to go with some butt hinges because I feel like it's probably the most common of the options. Doing some countersunk holes here for our backer plates. The tool that we're using right now is a CSR04A. It's actually a countersink bit that has a router on the front of it. That allows us to do the actual cutout for the backer plate or for the hinge, and then just move to the side and drill a little bit further to create that countersink. Great tool. It allows us to not have to do a tool change. But if you didn't have these tools, the robot would just simply go and switch back and forth between a countersink and a router. So when it gets done routing, it'll grab the countersink through your backup plates, move to the next position, do what it needs to do, and keep going. So that is our electric power transfer. That's a 9-inch cutout. So you get that big slug in there out of the way and do some backer plate holes for that. So we're going to switch cameras here. I kind of want to explain some of these clamps. I know Walter got into a little bit here. Traditionally, we've always used pneumatic clamps, air-driven clamps. On this machine and these bigger machines specifically, we went to these servo-driven clamps, and that's what you see this orange roller is right here. This is what allows us to move this total travel distance. So if you're running curtain wall or storefront, our travel is going to change from a 15-inch move to almost a 40, 50-inch move to clamp those smaller pieces. These are all fork-driven rollers. So as the piece of metal pushes through, these hold on tight to it. That allows us to keep our accuracy in place. And they move forward, in and out at whatever torque setting you specify. So on this door, let's say we want to run with 10 pounds of torque, but maybe on a smaller profile like a pocket filler, we can say in the library, hey, we want this pocket filler to not have so much power because we're going to bend it in half and our holes will end up being off. So with these, we have that control per part in a database that just says, hey, from now on with this part, let's use 3 pounds of torque so that we can consistently keep a nice clamping pressure and not have to worry about any kind of flex. So our hinge side is all done. It tells us that we want to eject the part or just grab it with our hands. I'll say eject so it can push us out for us. I'm gonna move this screen just out of the way here so that I can grab this door, show you the process. So the door comes out. It's gonna push itself out. If it was done and you guys didn't have any more preps, then you would obviously just take it off and move it around. But since this door is going to have lock side preps as well, we're going to use these ball tables to turn it around and get it ready for the other side. So I'm just going to simply just turn this door, rotate it on these balls. Moves nice and easy. Push this back through. Oh, if you guys want to see some of these hinges a little bit closer, we're going to show you a little closer up look too when this gets done. I'm just going to push this through. The screen tells me, hey, rotate doors so that the lock is along the back fence. So I'm going to hit OK. I'm going to push this guy through. And I'll just make my way over to this side too and make sure I'm tied up against my pusher. And then press this continue button like we did the first time just to say, hey, okay, I'm ready, start running. So on this side, you're going to end up with an MS-1850 lock cutout with some cylinder holes, backer plate holes for that plate on the front. You're going to end up with a 10-inch pull handle with the sex bolts on the other side and a latch cutout across the top of the door for deadbolt lock. So as it pushes and gets itself into position here, you'll see simultaneously now, these routers are all moving at the same time. We have this theory called multi-threading, and it allows all 3 routers to simultaneously work within a window as long as we're not going to collide the router bits together. The software will automatically say, hey, I have a 1/4-inch window here. I'm not going to hit my bit. I can run these together with no issues. Okay, it gets those done, pushes a little further to another position, and runs the routers that it needs to. So at any point during any process where you guys are running curtain wall or storefront, or you guys are running sunshades, anything you guys can think of, we can run simultaneously all together, and you won't have any issues getting things done quickly. So I'm going to pull the screen over. We're going to have a tool change coming up here, where we need to switch the back router to a different router bit. So it says click OK to change the tool to EM14A. So when I hit OK on this, we're going to run through that same routine where the robot goes, hey, I have a different prep on this door with a different tool, so I need to move into my position, and I need to switch out my tools. So all of this is set up in the database that says, hey, I have this router that I need in this position on my carousel. So the carousel spins around, it goes to the position that it needs to, it goes and grabs the correct router bit, spins it around, drops that other one off that we picked up earlier, makes its way back to the router, switches things out, and then just continues to work as he goes through it. So when we set all this stuff up, you guys have control as users to say, hey, in this position, I have this one, I have an extra of the same, or I have 20 positions on this carousel. Well, I can put ultimately any bit that I want to put, right? And you tell it, this bit's in this position. And then from then on, as these things start to move around and the machine picks things up and moves them, it keeps track of every bit in every position so that it doesn't have to be fed by you every single time where to move to and what position to grab stuff from. Okay. There's our bolt cutout. So eject the part. I'm going to say yes. Then I'm going to show you guys these cutouts and everything, and then we're going to go ahead and just switch right into curtain wall and walk through some curtain wall cuts and preps and different miter and bevel options that we have with the machine. So spinning around, we'll kind of zoom in on some of these preps here and show you the quality of these cutouts, the smoothness, the accuracy of this thing. You can rerun this door over and over and over again, and you'll end up in the same exact position every single time. So you have a cylinder that measures this door to make sure that, hey, we're going to the same point every time. So on this side too, here's our MS-1850 with our little slug still left over in here. The lock cutout, the actual bolt cutout here, some backer plate holes. Here's your sex bolts up here. And then up here is just that cutout that we made for doing the top latch cutout. So pretty straightforward door here. Again, if you guys have any kind of hardware prep, I mean, MS-1850 is obviously a very common thing. Butt hinges are very common. So we kind of went through, you know, what would these guys see and probably recognize making these cutouts. So I kind of picked the most generic things. As you start to get into some panics, it just looks like holes and little circles, and a lot of people would look and go, well, what is that? You know, so we didn't go that route. So we're gonna hit OK. It says, hey, we're done. I'm gonna pull this door off of here, just set it off to the side so that when we're running curtain wall, it's not gonna be in our way at all. So in this case, I'm just going to pick this curtain wall job, and we're going to walk through what you guys saw as the same exact process as before, right? It's going to tell us, hey, you know, you have this door, you need these tools. We're going to hit OK, let this machine do its thing. But on these, you're going to see some countersunk holes. You'll see some shear block attachments. You'll see bevel cuts, and you will also see miter cuts. So I'm going to hit retry on that because I had to close this door. Fab list. Select the part number we want to run. We're going to hit OK on these. We'll hit next. And here it's telling me I need 2 stock lengths at 120. So like Bill was saying earlier, due to some of the constraints, our shop right now is completely packed with machines, so we didn't have much room. We built a smaller one. So these are going to represent our stock lengths just at 120. Obviously, in a bigger facility on a full-size machine, you have to have longer ones, but this one's just saying, hey, grab me 2 at 120, because that's what we can fit. So I'm going to hit next. It's telling me I'm going to cut 3 pieces out of this stock length, and out of the next one, I'm just going to get 1, and I'll have this big leftover usable drop, and that'll be it. So I'm going to go ahead and hit the start button. It's going to move everything into a position. I'm going to run these auto loaders so you guys can see this, how it automates this and pulls everything in automatically. If you guys don't want to use the auto loaders, if you guys are just running one piece, you can simply just walk it up to the orange rollers up here, and you just set it down and say, hey, you know, I'm here. I'm going to hit this button. We're going to make it nice and quick. But if you guys obviously have 5 stock lengths, 10 stock lengths, load this thing up. Let this thing do its job and run through it. So, for instance, you want to come over and point in there, and we'll kind of toggle back and forth between the different screens so that you guys can see the back view of it doing the countersinks and the top view of it doing some other stuff. So on these, we have just some traditional horizontal curtain wall attachments. And if you see this back camera, those holes were at an angle. And the reason we did that is because this is actually going to be bevel cut as if it was a rake top frame, and this was a head going on a rake top frame. So when you see this cut, you'll see that cut at the same degree that those holes are set to.
And David, this is Todd. Maybe at some point while this is running, either you or Walter want to mention a little bit more about the routers themselves.
Yeah.
Okay.
Router, optional high-speed router. Like I mentioned before, they go up to 36,000 RPM. They're 9 kilowatt. Our standard router is 5.6 kilowatt, 18,000 RPM. And this new high-speed router also works with a
So here's the bevel saw. We're going to switch over so we can see this. Sorry, Walter, don't mean to cut you off. Make that cut, drives back in. And then we're going to get ready. And I programmed this to have a miter cut on the same piece. And we're going to flip back and forth and let both of these run at the same time to kind of maximize what we can show you the capabilities of the machine. So just a 45-degree miter here, cutting through this piece. So when it gets done, the machine tells us, hey, we're ready to go, and I want you to take this part out. So I'll pull the part out. I'm just going to dump the shavings into this bucket, wipe some stuff off, and we'll
label.
Yep, get a label on it and kind of just walk you through what we ended up with. So you have your standard horizontal preps here, and then we did some shear block preps on the top and bottom with both sides, and then some on this side also to follow that angle for shear block prep. Okay. So when we're running this, if we end up with some of these smaller pieces, what happens is the software wants you to pull these things out or knock them down into the thing because we don't want to push these little things to the trap area. So it shuts all the saws out, gets itself out of the way so that it's safe for you to move these little things out of the way. So these new gantries and these high-speed routers, you can see these drill bits moving in. We're going actually at 1 inch per second into these parts. It's quite a bit faster than some of our other machines with the feed rates and how quickly these things can move. It shows you just the sheer advantage of having it. Same thing here. Pull this guy out, dump the shavings, you grab the label, label it up, and then put it on your rack, ready to go. So this is going to cycle through. It's going to run a whole nother stock length after this and keep going. So if you guys want to open up some question and answers while this thing runs through, if you guys want to see any specifics, maybe zoom in on some stuff while this is running, now would be a good time while it finishes up this stock length and starts the next one. If you guys have questions, please unmute, ask away, let me know what you got. Assume someone's got some questions. I've been getting quite a bit of text messages from some of the viewers with some great constructive feedback. So,
as I was saying before, our spindles are water cooled because of the high RPM. There's a heat exchanger unit that's fully automatic with a thermal control system for all 3 or 4 spindles. And another thing I forgot to mention earlier is our fully automatic oiling system. We're using synthetic oil, and we have it programmed on every tool. It's adjustable of how many drops per minute you want to put out. And this way the operator, again, doesn't have to worry about it, makes it very simple to run the machine. And the oil will evaporate within 5 minutes and does not leave any residues, which also in turn keeps the machine very clean. Even after 10 years, the machine is going to look just like it does today. And here you can see another auto load maneuver.
yep. So it just finished up that first stock length. It just automatically loads up the next one and gets ready to go. No feedback from the operator. It just knows, hey, I have another one, so I'm going to keep going. It's going to push through. And this one, I set it up so that we would have a usable drop, so that the cutoff at the end is enough to want to save. This way we can show you what the machine is going to automatically do so that you're not going to end up with some jagged 45-degree pointed drop leftover piece of metal. So this one's going to run through basically the same process here. And then we're going to have the drop, and it's going to 90 cut it so that you don't end up with a drop that's 45 degrees leaning halfway over on your wall.
Hey, David, this is Todd.
Sure.
Questions have been pretty limited today compared to yesterday, but there was a question: can the machine be set up from a right-hand orientation, versus left-hand?
Yeah. So as you guys get working through the process and you understand how it would flow best through your place, you decide, hey, I want this to be a right-handed machine, or I want this to be a left-handed machine, and we build it to order. Trim there. We should just get this cut off here. There we go. So again, here's your finished piece. It's a little small for balancing, but it works pretty good. So over here. So here it's gonna 90 this thing off for us. This way we don't have that 45-degree left over on that piece of metal. Okay. Releases the clamps.
Again, if there's any questions, feel free to ask. You should have audio controls now to either ask verbally, or if you still want to mention any questions in the chat box.
One thing I would like to add too is, even though we have everything fully automated and it's got a lot of moving things on this machine, but we always try to keep it as simple as possible for the operator, to where you don't have to be a CNC operator to operate any of our machines.
Okay, questions? Bill, you want to take over and kind of direct some questions, or see if anyone's got any feedback? No, Bill? Okay, I'll take it. If anyone has questions, please feel free to reach out to Bill, me, Walter, anybody here can answer any kind of questions. If you guys have questions right now, feel free to unmute or type it in the chat box.
Okay. Okay, yeah, Todd, I was taking calls from everybody here,
No problem.
Okay, they want to wait till after it was over, So, okay, so yeah, so everything's ran pretty good, so looks pretty good. So if you guys have any questions, feel free to send me an email, shoot me a phone call, as you already are. If you need a quote, and the two guys I just talked to, I'll send you a quote right over. So if you guys have any questions, feel free to contact me, okay? All right, thanks for coming in, guys, and you have a good afternoon, okay?
Thank you.
Thank you.